happening, everyone? So this video is for questions 7 and 8 on the mixed exercise 12 lesson for this week. So the previous two questions we were looking at figuring out maximums and minimums. Same sort of thing here, except both of these times, and this happens a lot in exams, you're actually given the diagram, okay, which makes it really easier, if anything. So let's have a little look at question 7, and then I want you to go and have a go at question 8 on your own. So the diagram shows part of the curve with the equation y equals f of x, where f of x equals this. So effectively that just means that y equals 200 minus 250 over x minus x squared. The curve cuts the x-axis at the points A and C. The point B is the maximum point on the curve. Okay? Find f dash of x. Remember, that just means differentiate it. So let's have a little think of what we want to do. To figure out f dash of x, we need to differentiate that. That is going to be important as well, isn't it? Okay. So part A, find the differential. Before we differentiate it, let's write it in a format where we can differentiate it. Like that. Okay. And you can't differentiate x when it's on the bottom of a fraction, so you must write it as x to the minus 1. So f dash of x times by the power decreased the power by 1 times by the power decreased the power by 1. Your constant disappears, so it becomes 0. Times by the power plus 250x decrease the power by 1 minus 2 times by the power decrease the power by 1. So we get 250 over x squared minus 2x. Okay. Part B. Use your answer to part A to calculate the coordinates of B. Well, B is a maximum. So B is where the differential will equal 0. So f dash of x must equal 0 at that point, because, remember, at that point the gradient will be flat flowing it across there. So we need to put this equal to 0. So we're going to get 0 equals 250 over x squared minus 2x, and then solve that. So put 2x over there, multiply both sides by x squared to get rid of this. So we're going to get 2x cubed equals 250. Divide both sides by 2. We're going to get 125. Cube root 125, and you will get that x equals 5. Okay. We're not finished just yet because we need the coordinates of B, which means I need y as well. So I'm going to do 200 minus 250 over 5 minus 5 squared. 250 over 5 is 50. 200 minus 50 is 150. Minus 25 is 125. So B has the coordinates 5, 125. Okay. Right, let's have a look at question 6 then. We'll talk through it and then I want you to have a go at that on your own. So, question 8. Diagram shows part of the curve with equation y equals 3 plus 5x plus x squared minus x cubed. Just a little thing here, remember on the previous question I was talking about how you knew which one of those things was a maximum, which one's a minimum, and when it's a positive x cubed, you get your maximum first, then your minimum. Notice this time you're getting your minimum first and then your maximum. Okay, so it reverses because it is a negative x cubed one. The curve touches the x-axis at A and crosses the x-axis at C. The points A and B are stationary points on the curve. Show that C has coordinates 3, 0. So what that means is, when x is 3, y is 0. So part A, all you're going to do there is basically just put x equals 3, y equals 0 into that, and show that when I sub 3 in there, it'll give me 0. Okay, dead easy. Part B, using calculus, that means differentiating and stuff like that, and showing all your work and find the coordinates at A and B. Or what you notice about A and B, they are maximum and minimum. So differentiate it, set it equal to 0, and figure out your two answers like that. And that will give you your x answers, and then make sure you put them back into this to get your y coordinates as well. So pause the video now please and have a go at that. Right, and then what you should have done was shown that if you do 0 equals 3 plus 5 brackets 3 plus 3 squared minus 3 cubed. And to be honest with you, if it's telling you to show this, you don't really even need to work this out. You know that x equals 3, y equals 0 must work in that equation. Okay, so you can just put 0 equals 0 and then like your QED, which basically says I've proven what you've asked me to prove. Right, part B. Using calculus, dy by dx. So let's differentiate this. 3 is going to disappear. The 5x will turn into a 5. The x squared will turn into a 2x. And the minus x cubed will turn into a minus 3x squared. Okay? So, because I want stationary points here, the minimum and the maximum, I'm going to set this equal to 0. So 0 will equal, and I'm going to rewrite this in descending powers of x. The reason I'm doing that is because I'm going to use my calculator to solve this, and it will want it in descending powers of x. So I want minus 3x squared plus 2x plus 5. So that's going to give me two answers. It's going to give me that x is 5 over 3, and it's also going to give me that x is minus 1. And looking at the graph, I can tell you that I'm along the right lines, can't I? Because I'm getting one negative answer, which must be A, and I'm getting one positive answer, which must be B. So now all I need to do is put that into here and figure out what I'm going to get for y. Again, remember, what you can do here is if you do 5 divided by 3, it means that whenever you press answer for the next bit, it will put in 5 over 3. So I'm just going to use that while I figure this out. So I want 3 plus 5 times that answer plus that answer squared minus that answer cubed, which gives me 256 over 27. So that's one coordinate, and this one must be the positive one, so that's got to be B, hasn't it? Then do exactly the same for this minus 1 equals, again, 3 plus 5 times your answer, minus your answer squared, minus your answer cubed, and we get minus 2. Actually, I don't think that's right. I think that's gone wrong there. Let's just try that one again. 3 plus 5 brackets minus 1, I'm trying to be too clever there, plus minus 1 squared minus brackets minus 1 cubed gives me 0, actually, yeah. Okay, y equals 0, so that means that the point A there must be minus 1 and 0. Okay, it couldn't have been minus 2 because I'm figuring out that, and that's when it touches the x-axis, isn't it? So I couldn't have a value that wasn't 0 for y. So those were your two answers there. Well done if you got them right.